All right, just like magic, I return with a whole new section. So next, for physical science, we're going to talk about kinetic energy, which is all about motion. So potential energy is about position, and you can change potential energy into kinetic energy. So if you think back to where I was talking about before with a rock on a hill or a car on an on-ramp or something like that, that has mass and it has gravity influenced by it, and has its position due to height, you can change that to kinetic energy. So if I drop a ball or a rock, let's say off of a cliff, that potential energy starts to change into kinetic energy. About halfway down its path before it hits the ground, it will have both equal potential energy and kinetic energy. When it hits the ground though, since its position is now 0, it will have no longer any potential energy, but will have kinetic energy. And as objects fall, they pick up speed or pick up velocity, which will influence the overall amount of energy in joules that will come out of that. So here's our formula for kinetic energy. So I got K of E is equal to 1/2 mass times velocity squared. So the way I put this in my calculator is like this. I go 0.5 times what I have in kilograms times my meters per second squared. And my answer is going to come out in joules. So the first set of problems we're going to do is just straightforward. I'm just going to go multiplying these in direct order. We're going to solve for them. Okay, my calculator, because I'm going to make one up as we go. And then I'm going to solve for some unknowns, as well as, again, showing you guys how they could be equal. So I'm going to split these videos up into 2 parts. This first part is just on solving it in a straightforward manner, and the next parts are going to be solving for unknowns. So the first problem I got for you guys, and using my formula, is I've got an object that has a mass of 25 kilograms, and its velocity, is equal to 5 meters per second. So I've got a mass, I got a speed. I'm going to use my equation, and I'm going to set it up just like I would in my calculator. So I got 0.5 times 25 times 5 squared. Now, you could solve this separately. You could go 0.5 times 25, or 1/2 times 25, so you get your 12.5. And you also do your 5 times 5 to get your 25 and multiply them together. But I've learned within using parentheses in my calculators, it's much easier this way. So if I punch it together like this, my answer will be 312.5 joules. So that's how much energy I would have if I had a 25 kilogram object moving at 5 meters per second. So let's see, number 2. Let's stick kind of with the same thing, but let's see what happens with our energy. So I've got another object whose mass is equal to 25 kilograms, but now our velocity is equal to 10 meters per second. So again, I'll plug it together just like this. I got 0.5 times 25 times 10 squared. And if I do that, I'm going to see that I now have 1,250 joules worth of energy. Now, the mass stayed the same, but my velocity increased, it doubled. And if you look at the factor of how we're solving these things, we're squaring our velocity. So though we just doubled our speed, we almost quadrupled the amount of energy that we have right here. All right? So later on, when we get into physics, we'll talk about some of the formulas we use, like the inverse square law and things like that to help you out. So let's get rid of this. And let's make up a hypothetical situation of you throwing a pebble at super, super high speeds. So let's say at a mass is equal to 0.05 kilograms. So that's super, super light. But your velocity, I'll write velocity for you guys instead of just V. So your velocity though, let's say it's 300 meters per second. So you had the strongest arm in the world / a rocket arm, literally at 300 meters per second, to throw this very, very small object. How much energy would you have? So let's set up our problem again. So I got 0.5 times my mass of 0.05 times 300 squared. Now, I'm gonna let you guys solve for that really quick. Well, I solve for it. And if you got 2,250 joules of energy, you would be correct. So this is how we solve just directly forward when we have our mass and we have our velocity given, and we just use this formula. But the next video I'm going to show for you guys or help you guys with is how to solve for the unknowns. And the reason I'm going to break these up is this is very straightforward. You're just multiplying, got a little squaring, no big deal. But next, we're going to have to see how we have to square root certain situations to be able to get rid of this squared notion. So we're going to do that. We'll solve for mass, we'll solve for velocity, and I'll do one again of two objects moving either at the same speed or the same amount of energy, and how much mass or speed is influenced by them. So I hope this helps explain things for you guys. This isn't always the easiest thing in class. You guys could ask questions, we'd have feedback, and be like, oh, yeah, okay, you got that? Okay, let's do this. This makes it a little bit more difficult, but feel free to leave a comment, leave me a private message. If you guys are struggling in any ways, reach out. A bunch of you guys have, and I love helping you guys out. That's why I teach. I love teaching. Otherwise, I wouldn't be down here in a classroom by myself. Literally, it's quiet. All right, take care. I'll talk to you guys in just a second.